Hello everyone, I'm back with another video, and in this video we are going to discuss some numericals which are related to class 9 ICSE chapter 1 first part. You can see on your screen the book's PDF file is already open, and so let's start with the first numerical. We can see wavelength of a light is given as 5800 angstrom, and we have to express that in nanometer and meter. So how are we going to do that? So let's write the first statement. Okay, my board is reloading right now. Let's wait for a few moments. Yes. So number one, wavelength of the light that's given is 5800 angstrom, and we have to express that in nanometers first. 5800 angstrom. Now, first part is express this in nanometer. So first thing that we need to know is how are they related? How are they related? That is, how is angstrom related to nanometer? Just try and analyze the different formulas that you know. How is angstrom related to nanometer? So we know that nanometer, we know that 1 nanometer is equals to 10 angstrom, or I can write 1 angstrom equals to 1 by 10 part of a nanometer. So here we have 5800 angstrom, which we can write this as 5800 by 10. That's equals to 580 nanometers, right? Now, next part was, I think it was express this in meters. So what is 1 nanometer? 1 nanometer, 10 to the power minus 9 meters, right? So I can write this as, we can give a arrow sign or therefore sign. 580 nanometers is equals to, it will be 580 into 10 to the power minus 9 meters. Now, obviously, we can't leave the answer here because it should be like correct to proper order, that is to the power 10. So we can write this as 5.8 into 10 to the power minus 7 meter. Now, why minus 7 meter? We know that 1 0 we can cut off from this 0, and here it will become to the power minus 8, and then 1 for 1 place of decimal. So overall 10 to the power minus 7 meter. Let's check the answer for that. I hope 5.8 into 10 to the power minus 7 meter, right? Second is, the size of a bacteria is 1 micron. Find the number of bacteria in 1 meter length. Okay, so let's solve it. Size of a bacteria, that means I can consider it as one bacteria. It is said 1 micron. Now 1 micron is how much? 10 to the power minus 6 meter. Okay, and total length, I think the statement was in find the number of bacteria in 1 meter length. So total length given is 1 meter. Now the reason for writing from micron to meter is that both the units have to be same. So now we need to find out the number of bacteria present in 1 meter of length. So number of bacteria, how are we going to solve this? Number of bacteria will be equal to total length by size of one bacteria. Total length by size of one bacteria. So now let's see. So total length is 1 meter and size of one bacteria is 10 to the power minus 6 meter. The units will get cancelled. 1 by 10 to the power minus 6 means 10 to the power 6 is our answer. Let's see. Yeah, it's the answer. Next one. Here the hint is already given. Do not expect any hint in exams and all. Question is very simple. Distance of a galaxy is given and speed of light is given. And we have to find the time. So the hint is already given. Time equals to distance by speed. Directly we can do 5.6 into 10 to the power 25 by 3 into 10 to the power 8. Now the tricky part is the calculation part, which everyone has to, be bang on if you have to be good in maths for this. So 5.6 divided by 3, we can write 187. That is, obviously, we'll not get 187 because it has to be in decimal. And then 10 to the power 25 and divided by 10 to the power 8, we'll get 10 to the power 17. So, yes. So 5.6 by 3 will give us 1.87 and into 10 to the power 17 seconds. So I don't think I need to show this, but for the convenience of all the students, I think I'll show it. So let's write distance. Distance given is, what was that? 5.6 into 10 to the power 25. 5.6 into 10 to the power 25 meter. And the speed of light, we all know, 3 into 10 to the power 8 meter per second. Therefore, time equals to 5.6 into 10 to the power 25. This is a basic question related to exponents. First, you can do 5.6 divide by 3. Point will come 8, 24, 2, 0, 6, 18, 2, 0, 6. So it's continuing. We can approximate, we can write the value here as an approximate one. So 1.87 into 10 to the power 25 by 10 to the power 8 means we write it like this if you have learned about exponents. So approximate value will get 1.87 into 10 to the power 17 seconds. This is our answer. Okay. Next one, let's see. Fourth one. So 589 nanometer is given as the wavelength. What is its wavelength in angstrom? So we already saw this similar type of question is there in as we solved for number 1 also. The wavelength of light is given 589 nanometer. Let's do it. This is number 4. Wavelength of light 589 nanometer. Now we have already done the relation between nanometer and angstrom. Please remember this, 1 nanometer equals to 10 angstrom. So we can write that 1 nanometer equals to 10 angstrom. Therefore, its wavelength in angstrom we can directly write 589 into 10 angstrom. So we get it as 5890 angstrom, right? Let's move on to the next one. Mass of an oxygen atom is given 16U. 16U. U is the unit for atomic mass unit. We have to find its mass in kg. So mass of an oxygen atom is given 16U. This one was number 5. Number 5. Mass of an O2 atom is given as 16U. Find its mass in kg. So before we find its mass in kg, we must remember what is the value of one atomic mass unit or how is one atomic mass unit related to kg. So what do you think? Recall all the formulas that you know because this type of relations must be known to you. How is one atomic mass unit related to kg? So tell me, how is it related to kg? As much as I remember, in my means as per my knowledge, it is 1 point means it depends on you are writing correct to 2 decimal places or 3 decimal places. So it should be one atomic mass unit 1.66 into 10 to the power minus 27 kg. 1.66 into 10 to the power minus 27 kg. But if in your book you are preferring for correct to 2 decimal places or 3 decimal places, yeah, here also I can see in the example that's given 1.66 into 10 to the power minus 27 kg. So this makes my work easier. Therefore, mass in kg. Otherwise, if it would have been given for correct to 3 decimal places, you could have taken 3 decimal places. So therefore, mass of oxygen atom in kg, what will be it? So 16 into 1.66 into 10 to the power minus 27 kg. Now please calculate and find out the answer. 16 into 1.66. This is the calculation, means the calculation part must be done by the students. I'll prefer that. Let's see it. You will be getting 2.656 into 10 to the power minus 26. You can keep the answer correct to 2 decimal place as well. There is no problem regarding that. Okay. Number 6. I think in the new version of the book where for the publication released in 2020, 627, this question is not there in the book. So I think this is a different one because as per their book, I think uh, they have a different set of question for this one. This is number, yeah, it takes 8 minutes. Yeah, they have a different set of question. For number 5, I think they have distance of the nearest star from the earth is 4 into, let me see if it is here or not. um Distance of a star, yeah, that question is not in this PDF, as this PDF is an old one. So I'll discuss that question too. For number 5, that question is different. It is in the latest publication that's given. And as much as I can see the question from another side, the distance here, I think, let me just copy and paste it so that it will help. Yes, I think this is the question. The distance of the nearest star Proxima Centauri from the Earth is this. Express it in light years. So the distance is given in kilometers. We can solve it in this way. Distance equals to 4 into 10 to the power. Here the copying, because it's copied and pasted from another side, it is different. So it is, the question is 4 into 10 to the power 13 kilometer. So 4 into 10 to the power 13 kilometer. And we have to express this in light years. So 1 light year equals to 9.46 into 10 to the power 12 kilometer. 1 light year, 1 light year equals to 9.46 into 10 to the power 12 kilometer. So this is the relation. The formulas must be learned by heart. So therefore distance, distance in light years, distance in light years equals to, what shall we do, into or divide? Since it is already in kilometer and we have to express this in light meter, so 4 into 10 to the power 13 kilometer. 4 into 10 to the power 13 kilometer. Here we can just simply express 1 kilometer equals to 1 by 9.46 into 10 to the power 12. This is just to make things easy for those who are slightly weaker in maths. So since our distance given is 4 into 10 to the power 13 kilometer and 1 kilometer is this. So therefore I can write 4 into 10 to the power 13 kilometer will be 4 into 10 to the power 13 into 1 by 9.46 into 10 to the power 12. So basically it stands as 4 into 10 to the power 13 by 9.46 into 10 to the power 12. So now this calculation has to be done. It is not, I know it's going to be a slight difficult task for all of you, but the easy part of this type of numerical is that you can write the answer to the nearest decimal place. So while you calculate this, I think you will be getting something. You see 10 to the power 13 and 12, that means 4 by 9.46 into 10, right? Now please do this calculation part, and I'm sure you will be getting 4.2 light years. You can do the calculation part and leave your answer correct to two decimal places. I'll just break down a bit for you. 4,000 actually, because we will add this two zeros for the two decimal places, and then in the numerator we will have 946, right? So once you do the division, you will be getting 4.2 approximate light years. So this was number 5 for the latest book. Now let's move on to the number 6. So number 6 is time is given 8 minutes for the light to reach the Earth's surface. Speed of light is given 3 into 10 to the power 8 meter per second. Find the distance from the sun to the earth. So let's do it. Time taken. I'm just writing time taken is 8 minutes. Let's convert it into seconds. 1 minute has got 60 seconds. So 8 minutes will be 8 into 60 seconds. That is 480 seconds. Now speed is given, speed of light is given as 3 into 10 to the power 8 meter per second. We need to find the distance, right? Distance from the sun to the earth. So therefore the required distance you can write. Therefore the required distance, or you can write the full statement that's given in the question. We know the formula for distance equals to speed into time. So speed is 3 into 10 to the power 8 and time is given 480 seconds. So I can directly write 10 to the power 9 and 48 into 3. So 8 3s are 24, 4 3s are 12 and 4. So 144 into 10 to the power 9 seconds. You can also, sorry, it cannot be in seconds. We are finding the distance. Second was for the time that I had written, right? So it will be in meters. And I think the question is in kilometers. Yeah, in kilometer. So let's convert this. 1 kilometer equals 1000 meters. So therefore I can write 144 into 10 to the power 9 meter, means 3 zeros will go off from here. 144 into 10 to the power into 10 to the power 6 kilometer. Now if I just put two zeros here, I have to add two zeros here. So 1.44 into 10 to the power 8 kilometer. Let's check it out. 1.44 into 10 to the power 8 kilometer. Because I'm telling you, what I did was convert the meter to kilometer first. So for that, 3 zeros goes off, because here from 1 meter we get 1 by 1000 kilometer, right? So 3 zeros got cut off. We just reduce the power, and then since I'm expressing this in the correct order, putting the decimal point here, so 2 zeros will be added more, right? So these are just simple numericals related to the exponents, and placing means expressing the number in the correct order. Next, last one, let's discuss. I hope it's clear. I'll just reduce the screen size so that means I'll just zoom out a bit for the board so that it helps you in going through the entire sum once again. Okay. I hope this is clear. In case you have trouble, you can pause the screen and check the sum once again. Let's move on to the next one. Distance of star from the earth is given 8.33 light minutes. What do you mean by this statement? That means the light from the star is taking 8.33 light minutes. That means it is traveling a distance of 8.33. Um, it's traveling a distance of 8.33 light minutes. So how will we express this in statement? So first, let's write down the statement. Distance of the star from the Earth is number 7. I'll just now zoom in a bit. Yeah. The distance is distance of the star from Earth is 8.33 light minutes. Now, when we write that, it's better to write as it is given here. Okay. So then first question is, what do you understand by the statement? So we can write it takes 8.33 minutes for light to reach the Earth. It takes uh, it this the statement means the statement means that it takes 8.33 minutes for the light from the star to reach the Earth's surface, right? And now this was the first part of the question. The second part is express the distance in meter. So we have to express 8.33 light minutes in meter. In meter. This is our second part, right? We have to find out how many, what will be its value in meter. So first we need to know what's the value of 1 light minute. What's the value of 1 light minute in meter? What do you think? Come on, I'm giving you quick time to just recapitulate what's the value of 1 light minute in meter. If I tell you 1 light minute in meter, quick, as I can, or as much as I know, it's already given in the book, like 1 light year equals to this many meters, this many kilometers. So please, same for the light minute as well. If I can show you on the screen as well, here it's given in the book for the light minute. So here we can see, where is the light year? Unit of time, lunar month. Where is light year? Let's. Leap year is there. In your book, it is given 1 year, light year. Oh yeah, I'm finding in the wrong place. It's obviously the unit of distance. So it has to be in the unit of length. Unit of meter, bigger units, astronomical unit. Light year is here. So you can see 1 light year is given. 1 light minute equals to 1.8 into 10 to the power 10. 1.8 into 10 to the power 10. I hope I'm not having any problem with my eyes. It is to the power 10. 1.8 into 10 to the power 10 meter. So 1.8 into 10 to the power 10 meter. Therefore, 8.33 light minutes can be written as 8.33 into 1.8 into 10 to the power 10 meter. Now let's calculate 8.33. 800 means the easy way of calculating, just express that in decimal. 18 by 10, and here we have already 10 to the power 10 meter. Now already the 3 zeros goes cut off. Whatever you get as multiplication, you can write into 10 to the power 7, because 3 zeros are getting cut off. So into 10 to the power 7 meter. Easily in the way I can tell you, means I'll just help you out with the answer, but calculation part you have to do. Okay. So 1.5 we are getting 15. 15 it is it will not be 15 surely. So 1.5 here it is given 1.5 into 10 to the power 11. Okay. So you can calculate 800. I don't think it's an approximate value given here. 8.33 into 1.8 means 833 into 18. Let's you can do the calculation. What was the value? 18 was there. 18, just a moment. Yeah, 833. 833 into 18. This part you can calculate in your rough space. I will be using a trick to just simply solve it into what was the value? 833 into 18. 833 into 18. Let's cross check what values are we getting. Okay. Yeah. So let's cross check. I can give that. Okay, I'm getting 14,994. 14,994. Right. So it can approximately be written as 1.49 into if we increase, actually let's not write like this, it's not the right way. We can write it as approximate 15,000 into 10 to the power 7 meter. Now in case means this is, since it's not in the correct way of writing expressing it in decimals in metric form, so we can write this as 1.5. Now how many places of decimal? 1 2 3 4. So 4 places of decimals will increase here. 4 places of decimals will increase here. In case you said that why 14,994 we write as 15 approx, you can write this as approx 15,000. You can leave your answer as 1.499 also. There is no problem in that. You can express this as in this way also. 1.4994 into 10 to the power 11 into 10 to the power 11 meters. Right? So here also there is no problem in that. It's absolutely correct. It's absolutely correct. Okay, so I'll just decrease the screen. It will help you out with the answer on your screen. Okay, so these were the 7 numericals which were given in the first part of chapter 1. I hope this will help you to do certain revisions and to see how the calculation needs to be done. Okay, formulas are very important. You all must learn it by heart and practice. Give it means test your skills. Do some writing practice, because without that, it's going to be a mess in exam. So I'll end up here. I hope you all like the video. Please do like, subscribe, share. Okay. Thank you. Take care. I'll just stop the recording.